Turn and talk with that first question. Explain the difference between y equals x squared and y equals negative x squared. You look so cute in glasses. You too, you look so smart. What's the difference? Yes, more specific in terms of the parabola. So picture the graphs in your head. Yeah, so show me a parabola that goes up, that opens up. Show me with your finger. Show me a parabola that opens up. Curve, pay attention, nice. Show me one that opens down. Perfect, and that's because we talked about last year, that's what the negative does, is it changes the direction of opening. What we didn't talk about last year was just the vocabulary, is this is actually a vertical reflection. Vertical because it went from up to down. So you've actually done the first part of today. What you didn't do last year was horizontal reflections. Why not? Why didn't we just stick that in when we're talking about everything else with parabolas? Well, again, show me with your hands, fingers, whatever, draw in the air. Show me a up parabola, normal x squared parabola. Now flip it side to side. What happens? Does it change? No, that's why we didn't talk about horizontal, because it didn't change. But it will change cubics and square roots and all those other graphs. So here's what you need to know. Where's my highlighter? If the negative is outside the brackets in front of a function, it's called a reflection in the x-axis, which is in a vertical direction. If the negative is outside the brackets in front of the function, it's a vertical reflection. Let's jump down here to horizontal. Where do you see the negative is? Inside the brackets. If it's inside the brackets, it is horizontal. Where have we talked about that before? We've only done one thing so far, so guess. Translations, right? Inside the bracket we said was horizontal, outside the bracket is vertical. It's exactly the same thing with reflections. It all just depends where that negative is. If it's out in front, it's a vertical translation. If it's inside the brackets, it's horizontal. So let's start with a cubic example. And we're going to just draw the base graph of the cubic here. Cubic comes from the bottom, snakes up through the origin, and goes up towards positive infinity. And flipping it in a vertical direction means the bottom comes to the top's going to go to the bottom. And grab your red pen, or grab one from my bucket if you didn't have one. Bless you. Bless you again. And so if we were to flip this thing vertically, what's going to happen is it's going to start up in quadrant 2, snake through the origin, and go down into quadrant 4. There's your first reflection of a cubic graph. I'll come back to the box. I just want to go down and do the example for a horizontal. Let's do square root graph. Square root graph is the swoop to the right. And so a horizontal translation is left goes to right, right goes to left. So what do you think this is going to look like if we reflect it horizontally? Swoop to the left. There's your very first ever horizontal reflection. To sketch this graph, change the sign. of all y coordinates. That's what we were doing with parabolas. We just didn't talk about it in terms of switching the sign. So positive goes to negative, negative goes to positive. Now I'm going to show you something called mapping, which at the beginning is going to seem weird because you haven't seen it before, but it's a way to write that without actually using all the words. So mapping always gives the original coordinate, which is just xy. Then it gives an arrow, and what the arrow means in English is goes to, so xy goes to x negative y. It's called mapping. And what that is telling you mathematically is change all the signs of y. It's just not using the words. Horizontal, how do you think we're going to sketch the graph? Change the signs of all x coordinates. And to use the mapping to say the exact same thing without actually using the words, it always starts with xy goes to, and then we use notation to say change the signs, which means we're going to go negative x, y. And I'll explain the mapping again as we get into some examples. There's the theory. That's everything you need to know. The difference is where is the negative. If the negative is outside the brackets in front, it is a vertical reflection. If the negative is inside the brackets, it's a horizontal reflection. We're going to do the same kind of examples. So we're going to write the new equation, we're going to describe the transformations, then we'll actually get into some graphing. The graph of y equal to x squared x minus 3 was reflected over the y-axis. Write the equation of this transformation. Keywords. What would you like to highlight? The equation. Reflected y-axis. Right equation. And so visual people, what you can do when it says y-axis is actually picture the y-axis. And if I have something on the left and it's going to somewhere on the right, is that horizontal or is that vertical? Is it going up and down or going side to side? That's horizontal. So it's telling you it's horizontal without actually using the word. So over the y-axis means the same as horizontal. It's going from left to right. So we know we need to add a negative. All we need to know now is it outside the brackets or inside the brackets? It's going to be inside brackets because it's horizontal. So I'm going to leave the y. I'm going to leave the equal sign. I'm going to leave the square root. And I'm going to leave that negative 3. Well, remember what I told you Thursday about square roots and mathematicians being lazy? What was that little thing that I told you? We don't want to write the brackets, so we assume there is brackets here. So all I'm going to do is stick the negative with the x. If you don't like that and you want to include these brackets, you can include the brackets. There's nothing wrong with writing them. It's just, again, mathematicians are lazy. There's how we show our horizontal reflection. Let's just say the question had said over the x-axis. Where would I have put this negative? Outside in front. That's the only difference between horizontal and vertical. Outside in front would have made it vertical. Inside makes it horizontal. Describe the transformations made to y equals square or absolute value of x if the new equation is negative absolute value x plus 3. Okay, so what we're going to do is describe the transformations. I'm going to start left to right, so I'm going to start with the negative. Because it's a negative, that's a reflection. Because it's outside the brackets in front, that is a vertical reflection. Now that's not enough. Just like before, we couldn't just say horizontal translation. We had to actually describe it. We describe it with the mapping. So we describe xy goes to. And if something is vertical, it's always the y's that are changing. So x will stay the same. What will happen to y? Negative y. There's how to describe a reflection, vertical reflection and the mapping. Okay, what about the plus 3 in the brackets? Well, because it's a plus 3, it's a translation. Because it's inside brackets, it is horizontal. Because it's horizontal and a plus 3, it's 3 units to the left. There is describe the transformations. Questions so far? Okay, we're going to start easy with a parabola because your brain knows parabolas, and we're going to do a horizontal reflection to a parabola. They've told us all of this is the base graph, and so let's quickly review. There's 2 ways to graph parabolas. Anyone remember either way from last year? It's been a while. Vertex, width, direction. The other way is when it's in factored form, and this one isn't. So 3 pieces of information we need are the vertex, the direction, and the width. And if you don't think you're going to remember what those letters stand for, write out the words: vertex, direction, and width. Vertex of this parabola. -3 and -4. And you didn't know last year, but what we were really doing here were the 2 translations. This is where we were taking care of counting 3 to the left and 4 down. We did it right with the vertex. Direction, up or down? How do you know? Because the 2 in front is positive, so we know it's going to go up. And then what's this width part? What's going on there? So we know 1, 3, 5 is the standard width, but because we have the 2, it becomes 2, 6, 10. Oops. 2, 6, 10. Is that kind of coming back? Okay, so vertex, -3, -4. So again, that's where we were doing the 2 translations. We just didn't talk about them in terms of translations, but that's equivalent to counting 3 to the left, 4 down. Then how do we count this width? What do we do with this? Over 1, up 2 on both sides. And then over 1 and up 6. And then if we had room, over 1, up 10, which we don't. Join the points in a nice little parabola form. And we're going to do our first horizontal reflection, so I'm just going to put down the mapping just to remind us. XY goes to, horizontal reflection means X becomes negative, Y stays the same. So what does that mean to our vertex at -3, -4? What's it going to go to? +3, -4. Why didn't the Y change? Because it's not supposed to. It's a horizontal reflection. Y is not going to change. So grab our pen because it's our last graph. All we have to do is really just flip the vertex over the axis. So the vertex is going to go to +3, 4. The width isn't going to change. The direction isn't going to change. So we're going to count the exact same points. Over 1, up 2. Over 1, up 2. Over 1, up 6. Over 1, up 6. Parabola. All this stuff that I wrote over here on the right side, you don't need to have any of this. This is just showing you when you look back at the example. If you just had this, you would get full marks. Look away. Look back. Did we flip this thing over the y-axis? Did we flip the left from the right and the right to the left? Always look away and look back, because sometimes when you're looking at it, your brain will do weird things. Show me your thumb so far. I'm getting this. Reflections are kind of cool. I'm kind of getting this. Reflections suck big time. Good. We're going to do an absolute value, then we'll do a radical, then there's some time to practice. Sketch the graph of negative absolute value x plus 4 and state the domain and range. Jordan, you are on domain and range reminder duty. because I tend to forget. Domain and range, you have to remind us before we go on. Okay, base graph. So go here, take away all the negatives and positives and numbers. What's the base graph of this function? Is it a parabola? Is it cubic? Is it an absolute value? Is it a radical? What is it? It's an absolute value. So the base graph we're going to start with is just the absolute value of x. If you've forgotten what it looks like, always go back to table of values. If you remember what it looks like, don't bother doing table of values. Absolute value of -2. Absolute value of 1. -1. Oops. Absolute value of 0. Absolute value of 1. Absolute value of 2. Who remembers what the shape looks like? It's the V. Okay, so -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. Remember, if you give me gnarly, nasty graphs that aren't drawn with a ruler, I will not mark them. Would you like your surgeon to make a nice, neat, linear incision, or would you like him just to do a gnarly incision that goes all over the place? Okay, let's identify the transformations, and I'm going to go left from right. So the first thing I see is this negative out front. Because it's a negative, it's a reflection. Is it horizontal or is it vertical? I hear like little quiet verticals. Is it horizontal or is it vertical? Vertical, how do we know? Outside the brackets, outside in front of the function. The mapping says that xy goes to vertical always changes your y's. X negative y. The next thing I see is this +4. Because it's a plus, it's a translation. Is it vertical or horizontal? Vertical, y. Outside, and it is 4 units. The thing I like best about this unit is it's very logical. So it's always going to be vertical when it's outside. It's always going to be horizontal when it's inside. Negatives are reflections. Adding or subtracting are translations. How are we feeling so far? What order do we do them? We could do both at the same time. The reason I'm not going to is because when we have more transformations, you don't want to start grouping them because you're going to make a mistake. It's really easy to miss a point. Go back to what you learned in grade 7. You started in grade 6, you formalized in grade 7. What's the order of how we do everything mathematically? Bed mass. Okay, so does a multiplication come first or an addition come first? The multiplication comes first, so this is always going to be first and this is second. Reflections will come before translations. So I'm not going to go to red pen yet because my next graph is going to be the reflection. I'll go to red pen when I'm using the translation. If you're the point person, this is telling you what you need to do. That's why we like the mapping. It means change the sign of all the y's. So you can literally go negative, 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 and plot those new points. If you're more visual and you can go right from the graph, I'm going to go to this point, and I'm looking at the y's. So 2 is going to flip down to -2. You'll notice I didn't move it side to side. I dropped straight down to -2. 1 is going to go to -1. 0 is not going to change. 1 goes to -1. And -2 goes to, or +2, sorry, goes to -2. Okay? I didn't move any of those points side to side. I just flipped them over the x-axis. Okay, so if you like doing it with the points, do it from the points. If you can do it just from the graph, do it just from the graph. Going to red pen, because now the translation is going to be our last graph. If you want to go from the table of values, what are we doing? Are we affecting x or affecting y? It's y, and are we adding 4 or subtracting 4? So just add 4 to each of these if you want to work off the point. So -2 plus 4, 2, et cetera, et cetera. If you want to go right from the graph, go right from the graph. Again, I'm going to start with this -2, -2, and all I'm going to do is count 4 up. 1, 2, 3, 4. And it went back to its original spot, which is kind of cool. Next point, 1, 2, 3, 4. The origin, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Hopefully you can start to see if these were all the same color and you made a mistake, it's impossible for me to find what you think is the final graph. That's why the red is really important to me. I don't care what the other colors are. They can all be pen, they can be pencil, they can be different colors. The last one just needs to be in red. Look away. Look back. Look at your original, look at your red. Did we flip it vertically and did we bump it up 4 spots? How are we doing so far? Good, good, good. Sketch the graph of y equals the square root of -x, -2. Base graph, take away the negatives, take away the numbers. What's the most basic graph that this belongs to? Perfect. Again, you don't need to draw the table of values, but if that helps you and you like to do that for the transformations, then draw it, but you don't get any credit for the work over here, you just get for the graph. Give me the good points that we pick for radical x. I didn't hear the last one, but I think somebody said it. Perfect. The corresponding y values are square root, square root, square root. Yeah. So Kaylee, we talked about on Thursday that we don't pick, for example, 2 because the square root of 2 isn't a nice even point. So we're picking perfect squares. That's where the points are coming from. So 0, 0, 1, 1, 4, 2, 9, 3, swoop. What do you think it means when I do that in your notes? Yeah, it's important, it's an exception. It means the night before the test, when you're looking back through your notes, your brain needs to come back to this one. There's a little trick here with vertical reflections, and we're going to do next class vertical stretches. When you have a bunch of stuff here under the brackets or inside the square root or inside the absolute value or inside a cubic, you have to factor out a negative, and I'll tell you why in a second. So when you have a bunch of crap like this and you've got a negative in front, you have to factor it. So factor I know is a scary word. It's okay. I'm going to keep that square root. I'm going to keep my y equals. All I'm going to do is bring out a negative and put a bracket. And we know when we're factoring, what we're actually doing is dividing by -1. And so that's all I'm doing mathematically. And so if I take -x divided by -1, what does it leave me? X. And then -2 divided by -1 is +2. Why did I have to do that? Well, take a look if we didn't do it. What does it look like that 2 is? 2 units to the right. But here when we have it in its proper form, it's actually 2 units to the left. So you just want to make a note with horizontal reflections, factor the negative. With horizontal reflections, factor the negative. Horizontal reflections, factor the negative. So I'll flip back, you stay where you are. Why, when we did that first horizontal reflection, where did my horizontal reflection go? Oh, we didn't factor it because it was, where are we? Because it wasn't actually part of the equation, because it just gave it to you in words. If it had been in there, we would have had to factor it out. Okie doke. Let's identify the transformations. Obviously, that negative is a horizontal reflection, Kaylee? Shame, shame. I'm putting you on domain and range duty now. Let's just back up and do domain and range. So this is our first time doing it, so let's put all this domain and range crap back in our heads. Domain is all the possible x values, range is all the possible y values. What's the easiest way to remember which is which? Yes, but there's a little trick. Yeah, what comes first, x or y? Alphabetically, x. What comes first, domain or range? Domain. That's how I remember x goes with domain, range goes with y because it's alphabetical. Okay, so domain is when we look to the left and we look to the right. So we come to the left-hand side and we're like, where do we run out of graph? Well, what does this arrow mean? Keep on going forever and ever and ever. So what's the smallest possible x value? Negative infinity. And here, because of this arrow, it means we go on and on and on and on. So what's the greatest possible domain value? Positive infinity. Remember there was 2 ways last year to rate domain? So the first choice is negative infinity to infinity. If you don't like that way, there was that fancy little notation I just heard. X, E, R. It has to be the curvy E, so like an E, like a C with a line, because this actually isn't an E, it's a Greek letter. Anyone know what Greek letter it is? Epsilon. So you may have heard that before, it's called epsilon. What does it mean in English? Is an element of, belongs to the set of, is a part of this family. That's all it means, it's just a symbol. What does this R mean? The real numbers, and what are the real numbers? All of them, so whole numbers and integers and fractions and decimals and square roots and irrationals like pi and all those crazy numbers. And by the way, later this year you get to meet pi's friend E. Can't talk about it right now, but it's super cool. This is a fancy way of saying every single number. This is a fancy way of saying every single number. Pick and choose, it's completely up to you which way you like to do it. Whew. Range is all the possible y values. So range is when you look up and you look down. So if we go to the red graph and we look up, what's the highest possible y value? When do we run out of y values? 4. Where's the lowest possible y value? Well, again, what do these arrows mean? So the lowest is going to be negative infinity. So if you want to match the one above, we say negative infinity to 4. Or to match XER, anyone remember? Why? No, because it's not all the values. So do we want to go lower than 4 or higher than 4? Lower, so what's the symbol for lower? Less than or equal to 4. You either have the first notations or you have the second. You can't mix and match. You can't put a negative infinity and a y less than equal to 4. That's like giving one temperature in Celsius and the other in Fahrenheit. You can't mix and match like that. So you're either going with the first or going with the second. All coming back, domain and range. Okay. Horizontal reflection. XY goes to? It's horizontal, so negative XY. The 2, because it's an addition, it's a translation. Because it's inside brackets, it is horizontal. 2 units to the left. Any questions on the mapping or how we identified them or how we knew what was going on? What order do we do them? Reflections before translations. Why? Bedmass, multiplication before addition, subtraction. So we're not going to red yet because we're doing the reflection first, so go to some other color. If you like working off the coordinates, then work off the coordinates. All we're doing is we're changing the sign of x's, so change each of those. If you want to work off the graph, work off the graph. So here this 1, 1 is going to go to negative 1, 1, because I'm going from the left to the right. 4, 2 is going to go to negative 4, 2. 9, 3 is going to go to negative 9, 3. totally missed a point there. Pretend that didn't happen. Last graph, translations. Make sure you're flipping to red now. All we're going to do is take those points and move them 2 to the left. If you want to work off the coordinates, you're subtracting 2 from the y's. So 1, 2, 1, 2, 1, 2, and off the graph. Look away. Look back. Did you flip this thing horizontally, and did you shove it over 2 spots to the left? How are we feeling?